It's nice to see that so many people are interested in salad recipes. Okay, so today I would like to talk about Celery, and what Celery solves is this problem. Imagine you have a web request with your framework, whether it's Django or Flask. Your user comes to the site and triggers something, and the something could be update of user stats. You want to send the user an email. The email sending might fail. You want to process an order. All this long-running stuff. So when you look at this workflow, your user would have to wait until all your processes are done, and then your web request gets returned. That's a pretty poor user experience. And to get around it, you can use Celery. Imagine you go to this lovely site, and I don't know if you guys use that, but Adroll is using Celery, for example. And when you come to the site, you don't wait there for hours until they have calculated all the stats. So they have asynchronous tasks which running in the background. And you basically see the data, whatever is calculated to that point when you come to it. So when you use Celery, when you implement more salad into your stack, that means that whenever you come to the site and you trigger that long-running task, you would basically just send a message to your broker system and say, hey, whenever you have a chance, do this task. And then the user gets his or her contacts generated, and they can move on. So basically, in the next couple minutes, what I want to explain is what this is all about. Broker message or the broker queue and how we can run Celery workers. Here's a little example. So if I would write a really simple Django app where somebody adds a comment to a site, and then I want to determine the complexity of that submitted comment. If I would use this in a normal Django setup without any Celery, it would take me roughly a second to the 0.92 seconds. If I call Celery instead, it just takes me 0.03 seconds, but nothing has happened. In this moment, I just send a message to the broker and say, hey, whenever you have a chance, give this to the next worker, and the worker should calculate the complexity of that. But the user only has to wait like a very, very small fraction of the initial time. So what I would like to explain today is the following things. Just a little bit of terminology. There's a little bit of like what are certain terms, what are the meanings of certain terms. How to get started. Like how to get started, simple workflows, and then let's talk about some best practices and like how to do scheduling and tricks and tips. Okay, so what is Celery? Initially, it's negative calorie food. But in this context, it's an asynchronous task queue with scheduling support. So that means we can, as I just explained, we can outsource tasks, but also we have the chance to schedule tasks. We say, every midnight, I want to update the user statistics. That's something you can do with Celery. So as I briefly explained, but this is more formal, instead of running the task immediately, you would outsource this to the broker system, and you have Celery workers. They report to the broker system, and whenever they're free, they grab the next task from the broker system, and they work that task. So that's what Celery is all about. In terms of terminology, what do you need to run Celery? You need the Celery package to start with. It is an original Python package, but it also is available for PHP and Ruby and all the other languages. It's pretty sweet. You need a broker system or a message broker. You need to store your task queue somewhere. We'll talk about this a little bit later, but basically, you can use any message system like RabbitMQ. You can use a memory database like Redis, or you can use a database. And then you need a result store, because the task can calculate certain results, and sometimes they want to talk to each other, and they need to store the results at a central point where all the workers can talk to. And for this, you can use Redis, and you can use a database. Alec reminded me yesterday that using a database is suboptimal, because you have then a single point, and they're all write to the disk, and it can make the whole process really slow. So It's often not recommended to use the database, but if you're like in development and you don't want to have the overhead of running a message system like Redis or RabbitMQ, you can use the database. Okay, how would this look like? So you would register the task with the broker. That's a simple decorator. When the task is being called, there's a message being sent to the broker system, and then whenever the next worker is available, it would take the task from the queue, work it off or work on it, and send all the results to the results store. That's all what it does. You can end up in a situation where all the workers are busy, and then basically your queue becomes longer and longer and longer. So that's something you need to watch. And there's some tools I show you at the end of the talk how you can watch that. And you can also start them. So you can send your workers in like an indefinite state, and then basically everything comes to a halt, and your queue becomes longer and longer and longer, and nothing gets worked on. All right. What broker to use? Can you use? I just briefly mentioned that earlier. You can use Redis. That's my preferred choice because we often have this already in your stack as a memory database. If you need a high-speed queuing system, then RabbitMQ is your favorite choice because it's optimized for that. And as I mentioned, like if you already have a database, you don't want the overhead. Just go with the normal database, and it supports Mongo and like relational databases. When you look through documentations and other tutorials, they always talk about workers and schedulers. So the worker is a unit which is basically taking any task from the queue and just executing that task at any point in time. So you can say when the user clicks on a button and it triggers a Celery task, a worker would pick up the task at some point. There's also a beat, or sometimes they're called a scheduler, where you can say, I want this task to run every midnight or every day at midnight. And what the beat would do, it would basically just create a worker task at that time. And whenever the next worker is free, it would work on that scheduled task. How to get started with Celery? It's super simple. That's basically all you need to do to instantiate your Celery instance and to write your first Celery task. That's from the Celery documentation. So, by the way, the documentation is really amazing. It's a wonderful resource. But basically, what you do, you define the instance name of your Celery instance. You define your broker. In this case, we're using RabbitMQ. If you don't define it, Celery will default to RabbitMQ on your local host. And you define your first Celery task. So in this case, you would basically just print or return hello world. That's all.
They both have to be hello, the name of the function and the name of the Celery queue?
Yeah. This is a little bit more complex setup from a larger code base, but that's all you need to do in a larger Django project. You basically define your Celery app, and you basically load your settings, and then you auto-detect all your Celery tasks. This like 10 lines of code is the Celery instantiation of like a large code base of a local company. When you then start your Celery instance, so you would run your Django web server, and on the side you would run your message broker. In this case, would be Redis. And then another service you would run would be your Celery worker. And to call your Celery worker, you would just execute that command in your command line, Celery-A, your project, wherever Celery can find your Celery setup, and then you call worker. And what happens is when you start it, it just shows you the configuration, and it lists you all the tasks. And depending on what your logging settings are, you can see all the interactions with the tasks. So in this case, we use Redis as a backend, as a broker system. We use the database as like a result store, and basically there's one worker. So in Celery, you can say, please run like 10 workers or 100 workers, depending on what your machine allows. So how can you call certain tasks? So it's very straightforward. You write your normal functions in Python, and you add a decorator, which is the name of the instance of your Celery project, and then task. And then Celery will auto-detect it in your Django project, for example. And then you can call it later on in your code with apply async or delay. Both function calls do the exact same thing, except that apply async has the option of taking additional parameters. And I will show you them in a second. You have the option of linking tasks. So sometimes you want to update statistics, and then you want to send an email to maybe the admin. And the cool thing is you can run them asynchronously, and they don't need to be like bundled up in the same task. You can just say, in this case, I'm just adding numbers, but you could, for example, say, calculate all the statistics, and when it's done, send an email out. And the way you do this with apply async, you say the next following task will be add.s. And what .s does, it creates a signature of a task, which is sort of like an instance. You can also say .si, then it's an immutable instance. So, and the beauty of that whole setup is whatever the result of the first task is, will be passed to the second. So you can build like nice workflows of tasks. So I just mentioned apply async. You can pass additional parameters in there. And a couple of really cool features are you can say countdown. You can trigger a task, but you can say this task should only run like in an hour or in like 30 seconds. And that's what you would do with countdown. If you have a very specific time, you can also say ETA. And then you can also say only run this task, but only run this task in the next 30 seconds. And if it hasn't been executed, just kill the entire task. And that's something you can do with expire. So you can really build wonderful workflows. All these Celery calls, they also return data back to your call. And what you can do is you can say result.ready basically gives you a true or false whether the task was already executed at that point. You can then check on certain statuses. You can say, was it successful? Has it failed? You can get the result with like .get, or you can say .state, and it gives you the one of the 5 Celery states. So it's pretty sweet. You can programmatically check. Talking about a little bit more about workflows. So as I mentioned, one option is you can link the tasks, but you can also chain them with a pipe operator, which is pretty sweet. And then Celery has another function which is called chain, where you can basically build these longer workflow chains. Sometimes you have the situation that you want to run like 4 tasks. They can run in parallel. Let's say you want to update your user statistics. You want to process an order. You want to create a PDF, and when everything is completed, you want to send an email to the admin or maybe to the client. And one way to do this is you can wait for certain tasks, and the option here is court. So Celery will wait until all the subtasks have been completed. And another wonderful option, but I'm not explaining this here in detail, is chunk. So if you spin up 1,000 tasks, you can chunk it off into like bits of 10 and say every worker takes 10 tasks, and then when they're all completed, you can move on. One really great feature is scheduling tasks. Imagine you have a Python script. You want to run that script every night. If you can easily use a cron job for that, but the cron job means you need to set this up in your bash, and you need to set up a cron tab, and if you migrate to a different server, you need to move that additional file. So it would be really handy to keep everything in Python, and Celery gives you the option to do that. So there's a couple ways to define scheduled tasks. One way is you can set it up in your Celery settings. You can just say, run this task every 30 seconds, or run this task on the 1st of July, or whatever. There's the option of using DJ Celery, which is a wonderful tool because you would store your schedules in a database entry, in a database table. And whenever you migrate to a different server or you move with your database, you would keep your scheduled tasks. It's also really easy to deploy a task and to just schedule it in production. So let's say you have your Celery task, you write your function, and when the code is deployed, you can go into the Django admin and say, hey, I want to run this task every Friday. And if you change your mind later on, you don't need to change any code. You just change the entry in DJ Celery. If you don't want to use any of the database setups, you can also use a decorator called @periodic tasks. I haven't used that decorator, but Alec was recommending it. It's a good way to store it in the code base. When you then run Celery again, you will notice something. Your beat or your tasks are not working or not firing. And one thing is, besides the worker, you need to start the beat. That's a big mistake I did at the beginning, and I was wondering why nothing is working. And so you would, instead of calling worker, you would also start the beat. So you need the worker and the beat together. Celery comes with a command like dash or worker -b, but it's recommended not to do this in. It's not recommended to do this in production. So if you run Celery in production, you have two instances: the worker and the beat. All right. A couple of tricks and tips. One really amazing thing is self.retry. If you have a Celery task, sometimes they fail. Let's imagine you want to send an email to the user and your email backend, let's say SendGrid is down. You can easily say raise self.retry. And the standard settings with Celery are that your retry will happen after like 180 seconds and happen for like 3 or 5 times. But you can override this, you can create your own countdown, you can create your max tries, etc., etc. And you can say, there's even an option where it said max tries exceeded. So you can try for 3 times, and if it doesn't happen, then it logs something in your logger or something. You have the option of having multiple queues, and that's super handy when you have a very long-running task and when you have a bunch of small tasks. So you can put them in different queues. So it's like different checkout lines. But you need to start a worker for every queue. But you can specify your worker with like -q, and then you give the name of the queue. So it's pretty handy. People might ask, how does it work now when you have all these like asynchronous tasks and you write your unit test? You don't want to really wait until your task fired up or until your queue is like ready. There's a really simple fix for that. You can just define in your Celery setup, Celery always eager, and any asynchronous task will be executed as synchronous task. So just basically disabling that asynchronous feature. Okay. Since it's not really running in like your Django run server or something, you don't really see the standard output. And one interesting thing is like monitoring. So how do you see what processes are around? How many of them failed? How many of them have succeeded? How many of them are pending? You have different states. So when a process gets registered, then they're pending. They get marked as started as soon as the worker has picked it up. As soon as they're succeeded, then they get marked as successful, et cetera, et cetera. So Celery has a bunch of like command line tools, which you always execute with Celery -a and then your project name, and then you say status, for example, and it shows you how many nodes are running. You can say results, and you give the UUID of your task, and it will show you the result of that specific task. You can do inspect active, and it shows you all the active tasks which are currently running. You can say scheduled. It's another way in the command line to check how many scheduled tasks you have currently running. One really nice thing is, because people don't really like to do this in the command line, this is a wonderful tool. It's called Flower, and it allows you to look into your Celery queues through a web interface. And in my previous job, we used this in production. So basically, you log into your production server or to any node, and you would basically check all the Celery queues. And you can check on the brokers, you can check on the different queues, you can check on the different tasks, you can click on the UUIDs of the different tasks, and you see the return statements and all the keyword arguments with going into the task, et cetera, et cetera. So it's really wonderful to see something broke in my queue. Where's the bottleneck here? Is my queue getting longer? Do I need more workers, et cetera, et cetera? So it's a really wonderful way to inspect your queues. And starting this service is as easy as starting Celery. So you would do flower-a and then your project, wherever you can find the Celery settings, and Flower will pick it up automatically. It has some wonderful tools in terms of like password protection, because it's running in production. You don't want to, that should not be visible to most people. It runs on a certain port. You can change the port. You can give certain credentials. So it's a pretty useful service, and the installation is pretty handy. Okay, a couple best practices. There's a couple mistakes I made in the past. One big mistake I made was passing ORM objects to the Celery queue. That's a really big no-no. What happens there is Celery supports a bunch of ways how they interact, and one way is it can pickle anything, and it literally does pickle anything. And in my situation, I passed in an ORM object, it got pickled, and by the time the worker picked up the object was not existing anymore. And the worker sort of ends up in an indefinite state, and sort of like, I'm failing. The next worker picks it up. If you have a bunch of stale objects in there, and all of a sudden your queue gets longer and longer because everything is completely jammed. So a workaround is just rely on JSON communications between the workers and the broker. And in that moment, you can't really push any objects anymore. You would just submit the ID. And then your Celery task would look up the ID and would just say, hey, this object is not existing anymore. And then task is done. Don't use the database as a broker. Again, the recommendation from Alec, the disk write of the database would slow down the entire process. And you probably want to use a memory database in that moment. Use more than one queue. A lot of Celery setups have like a single queue because everything comes that way by default. But sometimes you have these like really long-running tasks. For example, imagine you work at Stack Overflow, you want to update all the user statistics. That's going to take a while. But if you just want to send out an email, the email task would have to wait until all the user stats are updated. Rely on retry. I've seen a bunch of, and I've done the mistake myself, functions where it's just like there's an error and I log it out to the logger and don't retry. But Celery has this wonderful function which is so easy to use. That's a wonderful tool. And then use Flower. It's always nice to have flowers around, but yeah. Alec had wonderful recommendations for best practices. And with that, I would say happy asyncing. And yeah.